Hi everyone, myself Rishikesh with the team Tech Titans. We prepared worked on the use case called financial fraud detection system using IBM Watson AI challenge. So this will use powered by the IBM Watson machine learning for the real-time transaction monitoring and risk scoring. So before that, I will just highlight the problem statement and the solution we built on that. The problem segment is like it's in a financial fraud cost the global economy over 5 million trillion and manually. So this fraud cost will be more than 5 trillion annually. So traditional fraud detection system have a critical flaw. They flag 1 in 4 legitimate transaction as suspicious, creating massive customer friction while still missing sophisticated fraud attacks. So usually banks spend more than $15 per transaction on manual review, and customers wait hours for legitimate purchase to be approved. So meanwhile, fraudsters exploit predictable patterns to steal billions out of it. So there has to be a better way. So we would like to understand in this problem statement, like the 5 trillion annual fraud losses is a major concern, and 20 to 30% false positive rate. So $15 per manual review cost and customer frustrations. So these are the sum of the a pain point in these financial the fraud system. So as a solution, uh, so we built an AI powered fraud detection system using IBM Watson machine learning that changes the game. So our solution combines 5 machine learning models: random forest, XGBoost, gradient boosting, isolation forest, and one class SVM into a powerful ensemble that detects fraud with a 96.8% accuracy while reducing false positive to just 3.2%. That's an 87% improvement over traditional system, and we do it in under 200 milliseconds. So here I would like to take away we use the 96.8% accuracy metrics, and then the latency is less than 200 milliseconds, and improvement happened here is 87%. Of the statistics. So I'll just quickly go through the this features here. So it comes with real-time fraud detection, ML-powered risk scoring, explainable AI, high accuracy, REST APIs, and comprehensive monitoring. So project structure looks like this. It's a source, config, models, and logs and test requirements. In source, we kept data processing. So usually here data injection and feature engineering will happen. So in ML model, ML training will train the models, ML models and evaluations, and real-time monitored transaction, real-time transaction will happen. So we invoke them, and in risk scoring engine with explainability. So and we use the API underscore service.py. So using for the invoking the REST APIs, and the utils.py for the utility functions. So we can do the configuration in .py as well. So we can add the configuration settings here. So as a quick start, we can go to this one and set up the virtual environment, and then activate the virtual environment, and then do the requirements, install the requirements for this. So we need to add this credential, IBM Watson credentials, watson.ml underscore API keys, ML URLs, and space ID. This one, and then for the training models, we have the source models here. Under source, we have model underscore training.py. So this will generate a sample transaction data, train ensemble of ML models, evaluate model performance, save train models to the models directory. And later we will run the API services and start and we will verify on the local host. So this will give the predict it will predict the fraud risk here. So all these transactions will invoked. We can able to see it. Batch transaction, real-time monitoring, all this stuff. So for testing purpose, I will try to yeah. So these are the testing individual models. How we can do that? I will show in the demo, but I'll just going through this as of now. And then we can using the testing with API curl as well. So this model performance. This we have a metric, four metrics here: the fraud detection rate, false positive rate, response time, and throughput. So the fraud detection rate is that we targeted more than 95% and achieved was 96.5%. So false positive rate less than 5% and achieved was 3.2%. So response time is less than 200 milliseconds. So the achieved is 45 milliseconds. Throughput is 10,000 TPS, but yeah, achieved is 12,500 TPS. So these are the risk scoring components. The risk scores is calculated 0 to 100 using the weighted components. So ML model scores is 40%, amount risk is 15%, location risk 15%, merchant risk 10%, device risk 10%, and behavior risk 10%. So these are the key features analyzed here: transaction amount and frequency, geographic location patterns, merchant category, device fingerprinting, time of day patterns, velocity checks, impossible travel detection, behavioral biometrics, and peer group comparison. So these are the decision thresholds here: 0 to 30 for the low risk, 31 to 70 medium risk, and 71 to 100 high risk for the block transaction and alert fraud systems. So we have kept a configuration option here. So we can add these as well: risk scoring weights, decision thresholds, high risk countries, merchants, so velocity check parameters, and API settings. And there is a log folder created, so which captures transaction processing details, model prediction, scores, risk factor analysis, performance metrics, and etc. So these are some of the security best practices we kept in mind while building a solution for this financial fraud detector. So the first one is the store. It stores Watson ML credentials in environment variables. We use the HTTPS in productions. So right now it is in pilot mode, but yeah, this can be done. So implemented rate limiting. So add authentication authorizations. So monitor for API abuse and regular security audits. So if you want to go for the production deployment, so we have to build the Docker. So here is the recommended Docker file, and we need to add all these environment variables. So all this stuff. So now I will go through this testing the individual models. So I'll be in my switch to VS Code now. So here is my code. So I'll try to go through this one by one. Okay, I'm already here. So I'm just running this for the first time data processing. I'm running the data processing here just to ensure all the data have been invoked. So this data processing Python script generate 10,000 samples transactions. So with the 200 fraudulent cases, and it loads at the 10,000 transaction from the sample transaction.csv. So this has been already uploaded. Yeah. So this has been completed. So now I will train the model now, ML model. So I'm running the model underscore training.py. So you can see here all the feature columns and everything has been populated. So now it is training the models with these samples. So training pipeline completed successfully. So now I'll try to inject real-time no, transactions, and I will run the risk scoring as well. Yeah. So I already running that API services in other terminal. It is already running. So this is if I run, yeah. So here you can see the risk scoring for all these transaction. So test case one is the normal transactions. It's calculated risk for the transaction. This one risk score is 20. Decision is approved. So risk assessment report is this will approve high one. So it will give the component scores M1 ML score 100 out of 50. So weighted 20. So amount risk, location risk, everything has been located here. So top risk factors. So as of now, no. This is a normal transactions. So second transaction we invocated is suspicious transactions. So here the calculating risk for the transaction is it will calculate the risk for transactions, and risk score is 32.25. So decision is challenge. So risk assessment report is risk score is 32.25 out of 100. Decision is challenge. So action is additional verification required. Confidence level is medium. So here the component score happens. So ML score is 50 out of 100. Amount risk is 25 out of 100, and location risk, merchant risk. So all these stuff will get highlighted. So here we'll get the top risk factors. So high risk location plus 4.5 points because of values en. High risk merchants and crypto large amount plus 3.8 points. So this will highlight. So similarly, I did demo for V one more transactions. So I will just invoke that. So this is for the video dev setup. I already done that. So now just I need to run this demo.video. Okay, so here I can walk you through on the same thing. Yeah. So here it has normal transactions. So where it will give so a decision is approved. All this. So there is no risk factor involved in it. But when it comes to the fraudulent transactions, it will give the decision as a challenge. and gives a score as 37.25%. So this is the short demo of our use case financial fraud detector. So thank you everyone. So we really enjoyed with this IBM Watson AI hackathon challenge. We learned a lot about it. Thank you.